All right, the last part of Unit 7 is the distance formula. So we're going to find the difference of all three sides of the triangle, simplify the answer. So if I look at side AB, that's right, sorry, AC, my fault. AC, it is 1, 2, 3, 4, 5, 6. So side length AC is 6 units. So there are 6 boxes on each side. Then for side CB, there are 1, 2, 3 units. So now to find the last side, which is AB, we're going to have to use the Pythagorean theorem. So it's 3 squared plus 6 squared equals C squared. So 9 plus, not 16. I don't know why I keep doing 16. 9 plus 36 equals C squared. Well, 9 plus 36 is 45, which is C squared. We're going to square root each side. And it says to simplify the answer, so I'm going to need to find what goes into 45. Well, 9 and 5 do. And the square root of 9 is 3. So 3 square root of 5 is side length AB. So we have all 3 side lengths answered. Number 2, points P, which is 1, 2, and Q, which is 6, 3, are plotted on a coordinate plane. Find the distance between P and Q. Round your answer to the nearest tenth. So we're going to do the Pythagorean theorem. So I need to make a right triangle. Well, this side is 1, and this side is 1, 2, 3, 4, 5. So 1 squared plus 5 squared equals C squared. 1 plus 25 equals C squared. 26 equals C squared. Square root each side. And it's approximately 5.1. So there's one way to be looking at that. But really, what we're looking at, if I were to talk about coordinate points from 1, 2 to 6, 3, I really have, I'm just rewriting this triangle over here. This side over here is really y2 minus y1, right? Because it's 3 minus 2. Do you get that? So it's 3 minus 2. And this top one is actually x2 minus x1 because it's 6 minus 1 to get 5. Do you understand? And this is our distance. So now, on the next slide, you're going to figure out what the distance formula is. So for the distance formula, it's the square root of x2 minus x1 squared plus y2 minus y1 squared. If you looked up above, the x2 minus x1 was really your side length A, and your y2 minus y1 is really your side length B. So ultimately, every time you do the Pythagorean theorem, you always end up square rooting, so that's why we have a square root, and you always square your A, you always square your B, and you add them together. So it's really just kind of a shortcut formula to use the Pythagorean theorem. So using this next one, instead of drawing right triangles each time, we are going to use the coordinate points we were given. So for side length AB, which is this one, it's going to be the square root of, so x2 is going to be 4, because that's the one farther over. So it's 4 minus 0 squared plus 1 minus 3 squared. So those are our coordinate points. So if we look at that, AB equals square root of 4 squared plus negative 2 squared which really becomes 16 plus 4, which really becomes the square root of 20. So now 20 is 4 and 5. So the square root of 4 is 2, square root 5. So there is the side length AB. Now we're going to look at the side length AC. So if we use 3 and 4 for our x's, so 3 minus 4 squared, and negative 4 and 1, so negative 4 minus 1 squared, we end up with 3 minus 4 is negative 1 squared, negative 4 minus 1 is negative 5 squared, negative 1 squared is 1, negative 5 squared is 25, so it's square root of 26, which actually cannot be reduced because 26 is 2 and 13, so that is simplified. And our last one, which is going to be BC, let's do 3 minus 0 squared plus negative 4 minus 3 squared. Again, it doesn't really matter which one's your x1, x2, as long as you are using these ones as your 2's and these ones as your 1's. So 3 minus 0 and negative 4 minus 3. That you're not switching back and forth which ones are your 1's and which ones are your 2's. So 3 squared plus negative 7 squared, which becomes 9 plus 49, which becomes the square root of 58, and the square root of 58 cannot be reduced, so that is your simplified radical.